Hi there. On the bench today, a Roberts Play 10 DAB and FM radio for repair. The fault description is no sound. The display is still very nice and clear, and because I don't have much DAB reception, I have to concentrate on FM. And indeed, there is no sound, even when I maximize the volume. Let's try the earphone output, and as a precaution I lower the volume again and plug some earphones in. Raising the volume again. But I can hear nothing coming from the earphones either. There is the possibility that the contact switching between earphone output and speaker is dodgy, so let's exercise it a bit. But that has absolutely no effect. Because troubleshooting could take some time, I power the radio from my bench power supply instead of batteries. The power draw of this radio is a lot, typical for DAB radios. With 110 milliamps, the AA batteries will not last terribly long. Roberts has added little arrows to mark where the screws are to open this radio. There are 2 on the top and 2 at the bottom, basically 1 in each corner. The top screws are much shorter than the bottom ones, something to remember when putting it back together. There's 1 more arrow pointing at the battery compartment, and yes, there is 1 more screw in there, another short one. It takes quite some wiggling, but eventually, with those 5 screws out, the back shell of the radio can be lifted a bit. It can't be removed completely because of the wires connecting the antenna and the battery compartment. I disconnected the battery cable from the PCB, and that allows flipping the rear shell out of the way far enough to give access. It is still connected with the antenna cable, but since removing this needs desoldering, I decided to leave that in place. The radio is surprisingly modular. On the right we have a PCB with a DC input connector and a filter circuit. On the left is another PCB that looks like the audio amplifier since the speaker is connected to it, and it also carries the headphone connector. A small PCB on standoffs from a large PCB seems to be the actual DAB FM receiver since the antenna cable connects to it. And finally, a large PCB spanning the whole length of the radio carrying the circuitry for handling displays, buttons and the rotary encoder. With a fault description of no sound, it makes sense to start by looking at the audio amplifier PCB, which consists of mostly a single chip. There is also a USB connector, probably for firmware updates. The PCB is surprisingly dirty. There are some black smears as if something tripped on it and then ran off. And the chip has so much goo on it that I can't even read the part number. Let's try some isopropanol on a cotton bud. After a while, the cotton shows that the goo is coming off, at least most of it. I wonder what happened here. I measured the caps with the LCR tweezers and they are fine, so the leakage isn't from there and the battery compartment looks clean. I suppose someone could have spilled something that somehow got into the radio. While cleaning did not fix the problem, it allowed me to read the markings on the IC. It's a PT2369-HT, and here's the datasheet. It's an audio stereo amplifier with 2 times 2.6 watts at 4 ohms, but do not expect hi-fi with a total harmonic distortion of 10%. It can handle 4 input sources, and the input selection and the volume is controlled digitally using an I2C interface. Of particular interest for me here is of course the mute function, which would explain the silence on both speakers and headphones. It gets worse from a troubleshooting point of view because there's also a sophisticated software mute and depop. I underline this which explains that after power on, by default the output is muted and must be unmuted by software before anything can be heard. This means a software problem or a broken I2C bus could also be behind the silence in this radio. But before focusing too much on this chip, let's find out if there is actually audio from the receiver going to the amplifier, because if there's nothing, the fault may be in the receiver. But there is indeed something that looks very much like audio getting into the board. In fact, two signals which make sense for stereo. So signal goes in but nothing out. The chip may be defect, and maybe those traces of goo were it spilling its guts all over the board. I examined the chip under a magnifier and spotted that pin 24 was looking suspiciously like a bad soldering joint. I could fetch another soldering iron with a very fine tip, but being lazy, let's try my normal soldering iron, which was ready for action on the bench. I just want to reflow pin 24. Oops, that was not in the plan. But it looks okay now, not pretty, I admit. But the speaker remains silent. For checking the headphone socket, I use this adapter with the scope probes connected between ground and the red wire, which is the right channel. And what do you know? There is no audio on the headphone socket. I connected an external amplifier to my headphone adapter in parallel with the scope. Yes, I can hear the station. And I can change the volume. So the chip, the software and the I2C buzzer are working. Looks like my soldering fixed part of the problem, but for some reason I still can't get the speaker to work when the headphone is unplugged. Always checking for the simplest explanation first, I unplugged the speaker from the amp to do a quick test if the speaker itself is working. I used the test tone from a function generator output, so the volume will be pretty low. An 8 ohm speaker is almost like a short circuit for the generator. But yes, I can hear the tone, so the speaker is fine. Time for a deep dive. Here is the pinout of the chip. We have 4 pairs of inputs and 1 pair of outputs. Pin 24, which I tried to reflow, selects between speaker and headphone. If it is low, the speaker is turned on. If it is high, it's the headphones. But since there is only one stereo output, how is it doing that? Actually, how is quite interesting. I hope you excuse the brief diversion. This is the application schematic from the datasheet, but it closely matches what's in the radio. The speakers are connected to the left and right outputs marked as plus and minus. The headphone outputs are connected via a capacitor between one of the speaker outputs and ground. Here's how this works. Instead of just one amplifier per output, the chip has 2 for each output. When speaker is selected, the chip feeds one amplifier with an inverted signal. The speaker, which is connected between the 2 amp outputs, sees double the peak-to-peak voltage than what would be available with a conventional configuration where the speaker is connected between amplifier output and ground. Realistically, it won't be the full 10 volts because the output can't go all the way to the rails, which is why the output in the datasheet is only 2.6 instead of the theoretical 3.1 watts. But let's ignore that for a moment. The headphone is connected between one of the amplifier outputs and ground. It sees therefore a much lower AC voltage, and if it had also 4 ohm impedance, it would just see 0.8 watts. If there is no signal, each amp output is at half the supply voltage of 2.5 volts. This is no problem for the speaker because both its terminals see exactly the same 2.5 volts which cancel each other, so the speaker sees no DC. It is different for the headphone. It needs to be protected from the 2.5 volts DC offset, so a capacitor blocking it is a must. To turn the speakers off, the chip simply changes the input into the second amplifier from being inverted to being not inverted. They now cancel each other because the speaker sees only the difference, and that difference is now always 0. Since the headphone is connected to only one amplifier output, it is completely unaffected by that and continues to work. Yes, the chip can turn the speaker on or off, but not the headphone output, which is always on. But you can't check that, because as soon as you plug the headphone in, the speaker is turned off. I hope with that little excursion the schematic makes more sense. Now, how does the chip detect the switching? If you look at pin 24, it has a 100K resistor R3 in series, and the other end of it is pulled high using R2, another 100K resistor. The schematic is drawn with no headphone plugged in, so the contact in the headphone socket is closed, which means that R5, a 1K resistor, pulls the junction between R2 and R3 low to enable the speaker. If a headphone is plugged in, the switch opens and R2 can now pull pin 24 high to turn the speakers off. While looking at this, I wondered why are they doing this so complicated, generating a signal to a chip to enable or disable speakers. After all, headphone sockets have been able to turn the audio to speakers on or off directly since time immemorial, but then I realized in this radio they can't do it any other way. Headphones are designed to use a common ground wire and a left and right signal. If the speakers use the same configuration, then the switching can be done by the socket directly. But in this case here, directly switching is completely incompatible with the bridge configuration of the amp and the floating speakers. It is quite an interesting design trade-off. If you want to use 4 AA cells, like in this radio, you need an amplifier and bridge configuration to achieve any decent volume, but then you can't use the switches in the headphone sockets in the normal way. The alternative would be a higher operating voltage, which would allow you to use normal amplifiers, but that would need more battery cells, needing more space. Now understanding how this is supposed to work, pin 24 is high with the headphone connector inserted, which is correct, but it's still high when it's removed, which is not correct. I tested the switch contacts and they work correctly. I wired a 2K resistor in parallel with my multimeter. You can see the resistance value. Switching the meter to DC volts and connecting it between ground and pin 24 directly, and the speaker comes to life, even though the level is not really zero. So the chip is working correctly, but something is keeping pin 24 high, and if my 2K to ground just barely works by pulling it low enough, the resistor that is supposed to do this, working through the headphone contact and an extra 100K, has no chance. With that I found the problem. Remember the rash solder job? This left a bridge between pin 23, the shutdown pin, and pin 24. After going over it with a proper soldering iron and desoldering braid, which I forgot to video, sorry, the solder bridge is gone. Here is what I think happened. Either both pin 24 and pin 23 or just pin 23 had bad solder joints. The effect was that SD was no longer pulled high and the amplifier was always in the shutdown state, no output with either speaker or headphone. When I tried to fix pin 24, I inadvertently fixed both pin 23 and pin 24, but I also bridged them. Because pin 23 is always pulled high, pin 24 was also pulled high. The amplifier was now working, but since pin 24 was now also pulled high directly through pin 23, only the headphone output worked. Unplugging it has no effect because the pull down from the headphone socket came through a 100K resistor to pin 24, while the pull up from pin 23 was direct and much stronger. I put the radio back together and it's working fine now. I looked for a station with just speech because of YouTube content matches, but receptions of this station isn't great. Well, the main thing, it works and changing volume works too. Connecting my earphones from the beginning turns the speaker off, as it should. I can faintly hear the sounds from the earphones. Here, let me lift them closer to the microphone and you should be able to hear them. Unplugging the earphones,
this is a fantastically well-drawn world. The landscape is so vivid.
And the speaker is back, so all is as it should be. And the repaired radio is ready to be returned to its owner. If you like my videos, don't forget to like and subscribe and help growing this channel. And consider becoming a Patreon. The link's in the description. Thanks for watching.